And welcome back, and it's the 4th of March, further maths, 5 a day, and let's just have a look at the first question. Okay, so the first question is a factorise fully, which on the face of it looks awful because that's an x cubed, which means you need to find a factor and then do it. But actually, because there is no constant term, I can just take out an x, which is going to give me x squared minus 9x plus 20. And now I'm back to sort of GCSE type factorising. Which two numbers multiply to make plus 20? Well, I know they must both be negative because that's a negative and that's a positive. So therefore it's going to be x minus 4, x minus 5. First question done. Next question. Work out the gradient of the curve of this at the point when x equals minus 4. Now, as you probably now heard me say many times, you can't do the product rule yet. If you can, brilliant, well done, do that if you want. But actually it's still easier to expand, isn't it? So if I expand the bracket, that gives me 2x squared plus x minus 6x, which is minus 5x, and then minus 3 times 1 is minus 3, which means dy dx is going to be equal to 4x minus 5, which means at the point x is minus 4, what do I want? I just want the gradient, so not the normal or anything. My dy dx, in other words, my gradient, is going to be 4 times minus 4 minus 5, which is minus 21. And that is first question done. Next question. George has the following 6 number cards below. How many 4-digit numbers can be made that are less than 5,000? So in other words, what am I doing? Oh wow, okay, this is quite difficult. So there's 4-digit numbers and I want it to be less than 5,000, but I don't care whether it's odd or even or anything else. So actually, okay, so not as bad as I thought. So less than 5,000 means the first number needs to be either 4, 2 or 1, which means that's a choice of 3 numbers. Once I've chosen one, there are 1, 2, 3, 4, 5 numbers left. So it can be any one of 5 numbers, any one of 4 numbers, any one of 3 numbers. Multiply these numbers together and you get 3 times 5 times 4 times 3, or 180. Actually, that wasn't as bad as I thought it was going to be. I thought it was going to be an odd number or something different, which means you have to do 2 different sets of values. Either way, question done. Next question. Find the value of... Okay, so it's just an index rule question. I'm going to convert everything to 2's. So 2 to the y times 2 squared is 4. So that's going to be 2y plus 6 is equal to 2 to the 4, which means y plus 2y plus 6 is equal to 4. Which means that 3y is equal to minus 2, or y is equal to minus 2 over 3. Not sure why I squished that in at the end, but hopefully that's all okay and we follow that one. Y is minus 2 over 3. Next and final question. Show that. Right, so these questions are often, sometimes you can go completely the wrong way and sometimes they fall out quite nicely. Sometimes it's really obvious what you're supposed to do and sometimes it's just not. I'm just going to kind of guess a little bit here. So I'm going to multiply. Well, let's do the step in between because I'm showing that. So 2 sine x tan x is equal to 4 cos x minus 1. Now, it must be the case, because I've only got coses and sines, or actually, technically, I've only got coses. So it must be the case that I take sine x multiplied by sine x over tan x, cos x, by switching tan x for sine x cos x. And that is equal to 4 cos x minus 1. Okay, I can kind of see how this is working now. So if I collect the first sine times sine is sine squared x, and if I multiply everything by cos x, that moves the cos x to the other side, which gives me 4 cos squared x minus cos x. Always keep in mind what I'm looking for. So I can see I've got my minus cos x, but I can't, I mean, I can see where it's going to come from, but I haven't got 6 cos squared and I haven't got minus 2 yet. So now I'm going to do the switch. So 1 minus cos squared x. Move everything to the left. Minus 4 cos squared x minus or plus cos x equals 0. Expand my brackets. I've done this the wrong way around, haven't I? Because I'm going to get minuses, but that's fine. So that's going to give me 2 minus 2 cos squared x minus 4 cos squared x. Plus cos x, is it equal to 0? Is equal to 0, yeah. Which is, now I'm normally going to have to do a step in between on it, even though I think we can all see where this is going. So that's minus 6 cos squared x plus cos x plus 2 equals 0, which implies that 6 cos squared x, multiply everything by minus 1, minus cos x minus 2, let's move this down because that's in the way. Minus 2 is equal to 0. What was I looking for? 6 cos squared x minus cos x minus 2 equals 0. And I have proven that to be true. I definitely did that one slightly more messily than it was supposed to be, but it was fine. We got there. Would have been more sensible if I'd moved everything to the right-hand side, but not a problem. Question done. Happy with today. As ever, let me know how you did, and I'll see you for the next one. Thanks all.